we will discuss CodeChef today. So let's start. Hmm. This is the first question. Okay. So 3-pointer is worth of 3 points and 2-pointer is worth of 2 points. So and we are given the number of successful 3-pointers and number of successful y-pointers. So the answer. Okay. Let's understand the answer. Answer should be total score, and total scores should be the contribution due to 2-pointer plus contribution 3-pointer. Like how we will calculate the contribution to a 2-pointer. It would be 2 times the number of 2-pointers plus contribution due to 3-pointers is equal to 3 times number of 3-pointers. So this is our answer. Let's write it down in the form of code. So x is 3-pointers. So 3 times x plus 2 times y. That's what we derived from here. Is there a possible case of overflow? No. Yeah. Let's move to the next question. A secret binary transmission is represented by a string s of length n. 0 represents silence, 1 represents pulse. Okay, number of pulse, that is 1, after at least one silence, that is 0, has already appeared. So like the statement can be confusing. So just let me explain the problem statement. Let's say this is the string given to me. What is a silence here? This 0 is a silence, and we need to calculate the number of pulse after at least one silence has appeared. That is the number of ones that are present after this 0. That is the first appearing 0. Okay. So what are the number of ones? 1, 2, 3, 4. That is our answer. So what would we do in form of algorithm? Find the first 0, then count the number of ones present after that 0. So how would we find first 0? Find the index of it. Like let's try run it on the test cases. This is the first 0 and these two ones. So answer is 2. This is the first 0 and there is 1 present after it. So answer is 1. This is first 0, no 1 is present. So answer is 0. This is first 0, 1 is present. So answer is 1. Okay, seems all right. So what would be the approach? Find index of first 0. Okay, calculate number of ones after that index. Simple enough. Since there is test cases, let me take test cases as input. You can note that n is 10. So no problem. Let's take it in the form of string only. Find the index of first 0. If the current index is 0, idx of 0 is equal to current index, and then break. Now what to do? Iterate from idx plus 1 up till n. If it's a 1, increase the counter by 1. Initially counter is 0. That is it. Let's run and try. Okay, I've defined it as ITX0. Is there a chance of overflow? N is 10. No chance of overflow. So let's submit it. Create on a hidden test case. Okay, so it's good enough to find the edge case in this question. Okay, what if there is no 0? Like, let me create a new test case. Like, let's write 111. What should the answer be? Answer should be 0. But is the ITX 0 updated at any time? No, it is not. So where would this loop start from? This loop would start from 1, because 0 plus 1, it was initially initialized to 0, and 0 plus 1 is equal to 1. So it would give answer as 2, but the answer should be equal to 0. Let's compile and check. Let's see, the answer is 2, but the answer should be 0. So what to do? Let's initialize it with n. The answer is coming as 0, so let's submit it. Yeah. Let's move to the next question. As far as I understood the question, is it says that we are given a permutation. Like, a permutation is an array where every element is unique, and it consists of numbers between 0 to n minus 1. Let's say if it's a permutation of size 5, it will contain all the numbers between 0 and 4, and in any order. Like, this is a permutation. Similarly, this is a permutation. Like, the arrangement can be different, but all the elements are unique and between 0 and 4. Okay, so each index represent a person, and the value at index represents the priority or importance of that person, and each person from the highest priority starts leaving the array in such a way that it minimizes the number of people it disturbs. Like, this 4 wants to leave, so there is 1% to the right and 3% to the left, so it will choose right, of course. So it will disturb 1%. Now 4 is removed, now 3 wants to leave. There is 1% to the right of it present, so it will just disturb 2 and move to the right, and 3 is gone. Similarly, this is the process. Like, let's go through the test cases. Constraint n is small enough, and sum of n over t is also small enough. Like, not small enough, it is alright for n and n log n. Okay, so what is the brute force approach? Like, just stimulate the process. Just like, let's understand for the test case given in the second last, like 1432. What would happen? Okay, so here permutation is not from 0 to n minus 1, it is from 1 to n. So it is 1432. What would happen? First 4 would leave, and the array would become 132. What is the disturbance? It would leave by left, so only 1 is, this index 1 is disturbed, so answer is 1 for leaving of 4. Now 3 will leave, it could choose any side, left or right, and answer would added by 1. So it is 2 totally. Now 2 would leave. It would leave just by moving rightwards. So no one is disturbed. Similarly, 1 would leave to the leftward. No one is disturbed. So it is equal to 2. So simulation is also a okayish approach, but won't work here because sum of n overall t is like 4e5, and simulation would take place in like choosing a number, then selecting either to go left or right. So it would be going to of n square. how to improve our logic. So see your observation. Ith person will disturb minimum of xi comma yi. Okay, so what are these xi's and yi's? X is the number of elements present to the left of I and smaller than p of I. Okay, so see this thing. So in 1 4, similarly, what is y? We will understand it. If you are not understanding it correctly, no problem. So for this test case, 1 4 3 2. Okay. So what is x? Number of elements present to the left of I. Okay, so what elements are present to the left of 4? It is just 1. And is it smaller than 4? Yes, it is. So let's build the x and y array here. So for 1, there is no element present to the left of it. So it's 0. So for 4, there is one element present to the left of it, and it is smaller than 4, of course. Similarly, for 3, 1 is present, which is smaller than 3, but 4 is not smaller than 3. So answer here again is 1. Similarly, for 2, 1 is present, which is smaller than 2. So it is 1. Similarly, for y, it says that to the right of current index. What is present to the right of 2? It is no element, so its value would be equal to 0. Similarly, what is present to the right of 3? It's 2. And is it smaller than 3? Yes, it is. So it's 1. I would be filling it now. 2 elements are present and 0 elements are present. Okay. So take the min of xi and yi for each index. It's 0, it's 1, it's 1, and it's 0 again. So answer is 2. And this is reflected in the answer. So what we will do, we will construct such x and such y, and like iterate over to the to find the minimum of all these elements, and sum of the minimums would be our answer. Okay, so okay, one of the way for constructing x would be binary search. Let's see how. Okay. Hmm. Let's create a vector temp. Now, what are we creating? Vector x and y. What is the size of x? It's n. And what is the size of y? It's n. Okay. Just insert would be a problem. Let me think for a minute. Okay. So the only option now I am currently left with is using PVDS. Let me see my template. Okay. Let me make you aware about PVDS if you do not already know about it. Like this is the template for PVDS. Firstly, these are the operations that can be performed using PVDS. Okay, what is a PVDS? It is a set, normal set, but with these two extra operations. Like order of key gives number of elements smaller than k uh, in the set. Okay, so and what do we need in x and y? Number of elements smaller than the current value of pi. Am I right? So this is the like actual implementation of or usage of PVDS. So remember this operation just now with a black box order of key, and let's use it. So ordered set st and vector x y order of key. Is it used in int format or okay int format? Okay. This was result in x of I, and then what we will do, we would insert the current element. Okay. Now similarly for y we start with n minus 1 and go up to the same thing. Just update the yi and st dot clear. Now what is the answer? Answer is minimum of xi comma yi for all index. So this was the real life implementation or usage of ordered set. Like I taught you about one functionality, order of key, and the other functionality is find by order. This is used to find the value at a given index. Let's say we have a set with 1, 2, 3, 4, and we want what is present at index 3. So it would give 3 in return. Okay, like we have 5, 6, 7, 8, and this is in sorted order, right? So what if we want to find what is presented at index 3? So it would give 7 as output. Okay, let's move to another question. Let me explain the question. Like we are given a binary string again, and CNT00 represent number of 00 substrings present in S. Like this is a 00 substring present here. I've highlighted it. Similarly here, and if we are given this as a string, there are two substrings. This 00 from index 2 to 3, and this 00 from index 3 to 4. Okay, let's move forward. And in one flip we can invert a particular, let's say, bet, and we want to find the minimum number of operations required to uh, make count of 1 bits greater than count of 00 bits. Okay. Okay, let's write down some of the observations. Let's say we had 3 consecutive zeros. Okay, if we do a bit operation on the middle index, that is the third index, what do it become? And what are the values of 1, 1 and 0, 0? If you try to observe, it's easy to see that the number of zeros have decreased by count zeros have decreased by 2 because this was corresponding to a 0, 0 and this was corresponding to a 0, 0. That is, this middle index was corresponding to two zeros and we have saved ourselves. Similarly, if instead of the middle index we had performed the operation on the second index, what would this have become? This thing. And what happened in this scenario? Like the count of 1, 1 has increased. City 0 plus equals to 2. I mean city 0 minus equals to 2, right? And in this case, what has happened? City 1 has increased by 1 and City 0 has increased by 1. Okay, what is the overall benefit? What do we need? We need to uh, make sure that CT1 is greater than equal to CT0, or let's say CT1 minus CT0 is greater than equal to 0. Am I correct? So what is the difference in this particular thing, that is city value equals to CT1 minus CT0. Okay, what is the change in value? Value plus equals 2. Similarly, in this case, if you see CT1 has increased by 1, CT0 has decreased by 1. So value increases by 2 again. So what is the benefit in both the scenarios? Benefit in both the scenarios are same. Am I correct? So these two cases are uh, similar, we can say. So what can we do now? We can calculate the value of initial string. Now, uh, if the value is in positive, good enough. If the value is in negative, like in this scenario, the value is -1. So what do we need to do? We need to do some operations to make it positive, and in one operation we can increase it by 2. Okay, what happens in one operation? Value plus is equal to 2. If value is less than 0, increase using operation. Okay, and in one operation it increases by 2. So our answer would be absolute of value, absolute of value divided by 2. Am I correct? Because it increases by 2 every time. So for 3, it would increase by -3. It would increase by 2, become -1. Then increase by 2, become 1. So two operations are required, which is seal of 2. Okay, let's implement it. if value is already positive. Just leave it. What is in the else part? This is the short form of, yeah, so value plus 1 divided by 2. This is the short form for seal with 2. Yeah, there's a problem. Let's debug it. Value is 0 initially. Okay, 1 0 0 0 1 0 1. Let's submit. We have got it correct. So the question is, we are given with a array. Let's understand it with a test case. Let's say 0 1 2. What we can do, we can choose a index I and a value x. We can choose an index I and a value x. Now bitwise XOR with all the elements between 0 to I with x. Let's say we have chosen x as 1, so and index as 2. That is up till this index, 1 based indexing. So what do? XOR every element with 1. And this is how our array transforms. Alright. And using this, we need to make every element in our array unique. Okay, let's move on to the observation part. Let's say we had 2, 4, 5, 4, 2, 5, 5, 2, 4. Okay, what do we see? These three elements. Okay, well, let's see the array from rightwards. This is our uh, vision, that is seeing from right to left. Okay, so 4 occurs first time, 2 occurs first time, 5 occurs first time. Now and again a 5 occurs. So this 5 needs to be transformed. Okay, and let's see what is the best way of transformation. Transform it to a very big number. Like, let's say, what is our limit? Just XOR x is greater than 0. Okay, so any bit can be set for that number. Like, let's say, if understand the bitwise representation of 5. Okay, let's say this is the representation 4 and 1 5. This is a bitwise representation of 5. Let's say the largest number that occurs in this array has set bit of 30, which is true because 10 to the power 9 is limited under 30. Okay, and we just set the 40th bit of 5. Then we can never have two numbers giving like, okay, first of all, what do we have? 40th 40th bit set for 50. We have a huge number, and it is obviously not equal to 5. And since this bit is set in all the numbers before it, only the numbers which were already 5 have transformed to this same number. Okay, this 5 transforms to x, let's say, and rest of the numbers transforms to other numbers y, z not equal to x, while this 5 will again transform to x. Okay, now similarly, this 4 is transformed to y, and this 4 is also transformed to y, and this 2 is transformed to z, and this 2 is also transformed to z. What do we see now? This x is different from this 5, okay, and this z is different from this 2, and this y is different from this 4. So this subarray from 4 to 9 is now completely unique. Now apply the same operation from 1 to 3. Okay, let's say we set the 41th bit now. It is sure that 41th bit was not set in any number present to the right of x. Okay, so this transforms into a unique new number. Like let's say this transforms into A, this transforms into B, and this transforms into C. Am I right? Now we know that whole array is distinct. I think you have got the observation up till this part. Okay. So what about the implementation? And what is the minimum number of operations required? Okay. Hmm. Understand this thing. If a number occurs second time, seeing from the right, okay. If it occurs second time, all the numbers, other numbers, not this same number, that that occur second time and are present to the left of it are resolved. Am I correct? Okay. Similarly, if a number occurs third time, then all the numbers that are present to the right of it, left of it, and occur third time, seen from the right, are resolved. Okay. So if a number occur nth time, uh, all the elements to the left are resolved, and the number of operation required is equal to n. Okay, because let's say 5 was present 5 times. Using this particular algorithm, we converted this 5 second 5 first, then third 5, then fourth 5, then fifth 5. So it is the number of operations required was equal to uh, its occurrence minus 1 times. Am I correct? So our answer should be equal to maximum of occurrence of any particular number minus 1. Okay, like say, let's see whether our thinking is correct or not. Okay, 0 is appearing 2 times, answer is 1. All the elements are unique, so maximum occurrence of any integer is 1, and 1 minus 1 is 0. Similarly, maximum occurrence is 2, answer is 1. The logic goes correct up till this part, and let's just write it down in the form of code. Let's create a while use loop multiple times. Let's create a map. What is answer? Answer is equal to max of answer comma mp1 of bracket I minus 1. Okay, let's just output our answer. And okay, so it says that our approach was wrong. Let's try out some other approach. Okay, I've got an edge case like if we write down 4 2 2 4 4. Okay, let's say First we did the number of operation with 8 with 4. Okay, this 4. Then what do our number transform? It transform as 10, 10, 14, 4. Okay, but it transform 2, 2, 4, 4. It transform as 10, 10, 14, 4. Correct? Now again, we need to apply operation because these two tens are matching. Let's say we did it with 16, so it's 26, 10. And what is the number of operations required? Two operations are required, and our answer was 1, which is wrong. Okay, observation is correct, the implementation is wrong, so let's improve our implementation. Okay, so what was my observation? Like, if a number occurs second time from right, then uh, other numbers to the left of it that okay, let's restart with our observation. Hmm, like, if we apply uh, operation on ith index, all elements from 1 to I become different from I plus 1 to n. Okay, so it's better to forget all the numbers from I plus 1 to n. And if, okay, because we have set a bit in this number from 1 to I, which was not present from I plus 1 to n. So this number became unique, and that's what we have to check in our implementation. So what did we do in our implementation? We moved from right to left. We checked if the current element has occurred before it. If it already has occurred before, then we need to apply one operations. And since we will all the elements present in the prefix of current index will become unique, so no matching can be done afterwards. So clear our map and then uh, just continue with the same process. Okay, let's understand this question. It says that initially an array is given where all the elements are binary, that is 0 or 1. We in one operation we can increase one element by 1. Let's say make it 2, or we can like do not apply operation and keep it same. And we need to apply the minimum number of operation such that the adjacent elements are not equal. In this array, no adjacent element is equal. But here, these two adjacent elements are equal and these two elements are equal. So we can apply one operation and make it 2, and there is no adjacent element. So what is my first observation? Number cannot increase from 2. Okay. Okay, there cannot be a number greater than 2. Let's say we had this, like 1 was sandwiched between two ones. Then what do we do? Just increase this 1 by 2. And it's guaranteed that none of its neighbor was initially 2. Okay, because it was initially 0 or 1. So the adjacent elements of these indexes have become unique. Did we understand? Okay, now we know that numbers can be either 0, either 1, or either 2. So we can use dp in this scenario, where dp of ij would represent minimum number of operation needed to make prefix 0, I or subarray 0, I good. And a good array is represented as a array where all the adjacent elements are distinct. All right. So let's go forward. First of all, take n as input. Now let's create a TP vector of size 3 with 0, 1, and such that the new a of I equals to j. Okay, so this is our DP state. Let's create a n plus 1 size DP, and let's also create a n plus 1 size vector. Okay, bracket I. Okay, if j is smaller than bracket I, then current element cannot be decreased, right? We can increase the element, we cannot decrease the element. So the new value should always be greater than equal to. Hmm. It's good to define does long in this scenario. What are the base cases? Initially, 0th index is 0. And what do we need to output? Minimum of dp of n 0, dp of n 1, dp of n 2. Is it? Yeah. Hmm. One more thing. If k is not equal to j. Okay, 102. Hmm. Okay. Let's understand this solution once again. Like initially, we observed that it's necessary that a number cannot increase from 2 because it won't be the minimum number of operations, right? Like increasing it to 3 would increase the number of operations while we can do it using 2 itself. Now we devised a DP state where we said DP at I comma j equals to the minimum number of operations needed to make prefix from 0 to I good. And what is a good array? Good array is an array where none of the adjacent values are equal. And what j represents the new value at ai, that the array at I is equal to j. It can be either 0, 1 or 2. So that's why we created dp 0, 1 and 2. Now let's go to the recurrence part. If our uh, like we can only increase a index, we cannot decrease it. So first constraint is the new value should be greater than the current value. Okay, and what do we do for previous value? For previous value, a represents previous value and j represents previous index value. Okay, and j represent current index new value. Here also new value. Okay, so uh, if k and j are matching, this is the case of adjacent same elements. So we need to remove that condition, and uh, for all the rest cases, we just update as minimum of what is the operation required to make current index as j and take the previous index as k. And at the end, the answer is minimum of either the last element is 0 or 1 or 2. And that's an accepted solution.